Good morning, students. I'm ready with my next video. I don't remember what is the video number. No, it was last video number. It's okay. Then today again on mathematics. My new video is on mathematics for class 10. This is very important. Pythagoras Theorem. The topic is Pythagoras Theorem. This is very important because it is useful in geometry, it is very useful in trigonometry and many other branches of maths. Very, very important theorem, and many times it has appeared in exam. Pythagoras Theorem. What is Pythagoras Theorem? What does it state? First, let's see the statement. Pythagoras Theorem states, the statement is, in a right triangle, a triangle in which one angle is equal to 90 degree. One angle, only one angle is 90 degree, and other two angles are acute. That means less than 90 degree. Such triangle is called right triangle. So, in a right triangle, so Pythagoras theorem is applicable to right triangle only. It must be a right triangle, right angled triangle. It must have one angle equal to 90 degree and other two angles acute. So in a right triangle, square on the hypotenuse, the side which is opposite to 90 degree, this is 90 degree angle, and opposite to 90 degree, this side is always hypotenuse. Hypotenuse is that side which is opposite to right angle. That is important, you have to know. So here in this triangle, here is 90 degree. So side opposite to this 90 is AC. So AC is hypotenuse here. So square on the hypotenuse is equal to sum of squares on other two sides. So square on the hypotenuse will be equal to sum of squares of other two sides. Other two sides here are AB and BC. AC is hypotenuse, and AB and BC are other two legs, other two sides. So square of the hypotenuse will be equal to sum of squares of other two sides. So we have to now prove this. For proving, I have written what is given. What is given here? In triangle ABC, this is triangle ABC. In triangle ABC, angle B is equal to 90 degree. 90 degree angle, right angle is at B. Right angle is at B. Now, to prove, what we have to prove? We have to prove that square on the hypotenuse. AC is hypotenuse, as I told you. AC is hypotenuse. Square on the hypotenuse is equal to sum of squares on the other two sides. What are the other two sides? AB and BC are the other two sides. So this equation we have to prove. We have to prove what? Square on the hypotenuse. Square on the AC hypotenuse is equal to sum of squares on the other two sides. Other two sides are AB and BC. Square on the hypotenuse is equal to sum of squares of other two sides. This equation we have to get. We have to prove this. Right? For proving that, we have to do construction here. We will construct. We will make some changes in the figure. Construction. We have to draw some lines. In construction, you can draw some lines. You can extend lines, you can do that, right? We have already done this in previous, I have shown you in previous theorems also. We have already proved theorems. I showed you my previous videos, you can watch on our channel. My previous videos are there related to similar triangles. This theorem is also related to similar triangles, okay? Now, what is construction? What construction we have to do here? We have to draw BD, means a line will go from B up to D, that will be perpendicular. Perpendicular makes 90 degree to AC. From B, we have to draw from B, this is point B, this is point B. from B, we have to draw a perpendicular. We have to draw a perpendicular on AC. AC. So perpendicular makes 90 degrees. So this will be 90 degree and this will also be 90 degree. Perpendicular. We have drawn perpendicular DB perpendicular to AC. Perpendicular makes 90 degree. So here at these we have this side 90 degree and this side also 90 degree. In triangle ABC, angle B is 90 degree. Right. Now, so to prove, we have done construction. Now let's prove. For proving, in triangle ABC, big triangle, and triangle ABC, the big one, original triangle, actual triangle, in triangle ABC, and in triangle ABD. ABD is newly formed triangle. ABD is newly formed triangle after drawing the perpendicular. A new triangle is formed. Here one and here one. Two triangles are formed, right? So we are now comparing original triangle ABC, the big one, with ABD, this one, right? ABD. If you observe carefully, in triangle ABC, angle ABC is equal to 90 degree, right? ABC, angle ABC, this angle is 90 degree. How do we know? It's given already. Angle at B is 90 degree. And in this triangle also, in triangle ABD, at D we have 90 degree because of construction. So angle ABD is 90 degree. Angle ABB is also equal to 90 degree. Right? ABB is 90 degree. It means angle B in big triangle, angle B is equal to angle D in small triangle, right? So we can do one thing. We can write it like this. We can write angle ABC is equal to ABC means angle B in big triangle is equal to angle ADB is equal to 90 degree. ADB means angle D in small triangle. Angle D in this small triangle, angle D is ADB, right? See, ADB, this angle. This is 90 degree. D. At D we have 90 degree. So these two are equal. How do we know this? For angle B is 90, it is given in the question. It's given. And for ADB at D we got 90. How? Because of construction. Because of construction we drew perpendicular. That's why we got 90 at D. So given and construction, you can write like this. From given and construction we got this. Right now, and in triangle again, angle A, if you observe carefully, angle A is common. Angle A is coming in big triangle. Angle A is coming in big triangle, and angle A is also there in this small triangle. So angle A is common. So it will also be equal. So angle BAC means angle A of big triangle. BAC, when I say BAC, it means angle A of big triangle, and angle BAD. When I say BAD, that means angle A of this small triangle. Right? They are equal because it is the same. BAC means A, BAD means also the same. So it is equal. Why they are equal? Because common. They are common angles. Common angle. A is present. Angle A is present in big triangle as well as in small triangle. So it is equal. They are equal. Right? Common angles are equal. Now, because in these two triangles, two angles are equal. So from AA criterion, in my previous video, AA criterion, I proved one theorem in my previous video, AAA similarity criterion, right? Angle. So here two angles are equal, so third will be definitely equal. In two triangles, if two angles are equal, then third will be definitely equal, right? This you have studied in 8th and 9th standard. Now, so therefore, now we can say that the third angle C is remaining in big triangle. B is over 90, A is over. Now which is remaining? B is over, A is over. So C is remaining in big triangle. So angle ACB is equal to angle. Which one is remaining in this small triangle? Which one is remaining? D is gone, 90, and A is gone common. So which is remaining? B is remaining. This one is remaining now. That means ABD is remaining. So is equal to ABD. This one is ABD, right? Small triangle. So this is remaining. They are also equal because they are remaining angle. They are also equal. Now all three are equal. So according to AAA similarity criterion, in two triangles, if their corresponding angles are equal, then the two triangles will be similar and their corresponding sides will be in proportion. So we can say that triangle ABC is similar to triangle A is corresponding to A because A is common, and B is 90, which is 90 in this small triangle. D is 90. So A, D, you have to write D. Here I have written B, but while writing similarity statement, you have to write corresponding angles. A is corresponding to A, C. A is corresponding to A and A. See the central letter. See the letter in the middle. A is corresponding to A. B is corresponding to D because D is 90 in big triangle and D is 90 in small triangle, right? So A is corresponding to A, B is corresponding to, see the middle letter, B is corresponding to D, and C is corresponding to B. See the middle letter, C here is corresponding to, here middle letter in this three, middle letter is B. So triangle ABC is similar to triangle ADB. Here I have written ABD, no problem, but while writing similarity statement, you have to write the corresponding. A is corresponding to A, B is corresponding to D, C is corresponding to B. Now these two are similar triangles. If they are similar, because their corresponding angles are equal, so from AAA criterion, because of AAA criterion, right? AAA similarity criterion. Because of AAA criterion, they became similar. Now, if they are similar, their corresponding sides must be in the same ratio. So, corresponding sides ratio we have to write AB divided by here AD. First two letters AB, here first two letters AD. They make one side, right? Then BC, second and third letter here, divided by here second and third letter DB is equal to here first and last letter will make one side AC, right? AC divided by here first and last letter AB. So we got three ratios, right? AB divided by AD is equal to BC divided by DB is equal to AC divided by AB. But here in these three, we need only two. We don't need all these three ratios. We need two. Now we have to choose two. Which two should we choose? That is important. Which two should we choose? We must choose two that have a one common side. Like here, if you take these two, all four sides are different. AB, AD, BC, BD. All four are different. No. All four must not be different. One must be common. See, in these two, if we take these two, then all four are different again. AC, BD, AC, DB, BC, DB, AC, AB. All four are different in this. What about this and this? First and last, AB, AD, AC, AB. Oh, we have AB here and here. We have AB. So first and last ratio, in this and this ratio, AB is common. So you can choose these two. Don't choose the two in which all four are different. Choose the two in which one side must be same. So here we have, in this ratio we have AB, in this ratio also we have AB. One is same, so choose these two. This implies AB divided by AD is equal to AC divided by AB. From this equation, we choose two, all three are equal, so we can make any two also equal. All these three are equal. So we can make this equal to this, this equal to this, this equal to this, this equal to this, we can do that. So this is equal to this, we did that. Now, from this, if you cross multiply here, so what does this imply? From this equation, if you cross multiply, take AB here. So this AB will multiply with this AB. So AB into AB will become AB square. If you cross multiply in this equation, if you cross multiply, AB will multiply with AB. So AB into AB is AB square is equal to this AD will go there. So it will multiply with AC. So it will become AC into AD. This is equation number 1. Keep it as equation number 1. We got one equation here. AB square is equal to AC into AD. This is equation number 1. Now keep it. Equation number 1. Keep it. Now again, once again, go to the figure. In triangle ABC and triangle ABC and triangle BBC, right? In triangle ABC and triangle DBC. In this one, in this small triangle. Previously, we compared ABC, big triangle, ABC, the bigger one, biggest one, we compared with this smaller one. Now we are comparing ABC, the big triangle, ABC with this smaller triangle. When we drew BD perpendicular, two triangles were formed, two new triangles were formed, right? So here in previous solving this, we compared bigger triangle ABC with this one. Now we are comparing this bigger triangle with this one. So same thing will happen and we will get another equation like this. We got here equation number 1, AB square is equal to AC into AD. So if we do this again, we will get another equation. Okay, now compare. So in triangle ABC, we know that angle ABC is 90 degree. Angle ABC is 90 degree. B is 90. In big triangle, we know from data, it's already given in data, it's given. Angle B is equal to 90 degrees. So B is 90. In this big triangle, B is 90. And in this small triangle, BDC, B is 90 degree. B is 90. So angle BDC. B is 90 in big triangle, D is 90 in this small triangle. Here D. This is 90 because of this perpendicular. We drew perpendicular. Perpendicular always makes 90 degree. Right? Okay. So we got here equal to 90 degree. In big triangle, B is 90. In this small triangle, this D is 90. B, D, C, D is 90. Therefore, they are equal. Right? That. What about angle C? If you observe carefully, angle C is present in big triangle. Angle C is present in big triangle. And angle C is present in this small triangle also. So C is common. Just like here, A was common. While doing this, A was common. A was common. Now C is common, right? So can we write like this? ACB. ACB. When I say ACB means angle C of big triangle. Angle C of big triangle. Angle C. ACB. C is equal to angle. Can I write DCB? Yes. DCB. DCB. C is common. C is present in this big triangle and C is present in this small triangle. Right? They are equal because here this is because of given and construction. And this is because common. Common means it is present in both triangles. Common angle C is present in big triangle as well as in this small triangle. Right? C is present. So C is common. Here C, here C. See the middle letter. When I write ACB, means I am talking about ACB means I am talking about angle C. See in the middle. See the middle letter. and DCB. When I write DCB, I'm talking about angle at C. See the middle letter. C, DCB, C, angle C. So C is present in both. So C is common, right? Now again, if two angles are equal in this ABC triangle and in this small triangle, two angles are already equal. If two are equal, then third will also be equal. So which is remaining? B is gone. From big triangle, B is gone, C is gone. So A is remaining. So BAC is remaining. BAC is remaining, right? In big triangle, B is 90, that is gone, C is gone, so A is remaining. So I wrote BAC. This angle is in big triangle, BAC, or you can also call it as CAB, no problem. BAC or CAB, I hope, will be equal to remaining angle in this small triangle, remaining angle in this triangle, right? Which is remaining? D is gone, C is gone. So which is remaining? This B is remaining here. This one is remaining. So that is CBD. You can call it as or DBC. DBC is remaining. DBC is remaining. Right? This is equal because remaining angle. When two are equal, remaining will also be equal. Remaining angles are also equal. Now, in these two triangles, triangle ABC and triangle DBC, this is smaller one, all three angles are equal. Their corresponding angles are equal. If their corresponding angles are equal, then according to AAA criterion, AAA similarity criterion, these two triangles must be similar. So let's write similarity statement. Let's write similarity statement. You have to write similarity statement very carefully. Take triangle ABC, similar to triangle. Now see here, A, see the middle letter. See the middle letter only, A. Here B, C, A is here. A is corresponding to B here. See the middle letter. A is corresponding to B. A is corresponding to B. And B here, in this B is in the middle here, is corresponding to D. B, middle letter. Don't take this A and C. B is corresponding to D, middle letter here, D. Because middle letter represents the angle. Corresponding to C. Here, where is C? In the middle. Here is B, here is C. C in the middle. C in the middle. C is corresponding to C. Because C was common angle, right? C is corresponding to C. Writing this similarity statement is very important by choosing corresponding angles. You wrote ABC here. Triangle ABC. Here now it's coming BDC. If you write BCD, that will be wrong and your answer will be wrong. You will not get the required equation. This is the required equation. You have to get this. You have to prove this. You will not get. So choosing corresponding angle is very important. Here also I showed you choosing corresponding angle. Now these two triangles are similar because of AAA criterion, right? Now if they are similar, then their corresponding sides must be in the same ratio. So corresponding sides. While choosing corresponding sides, choose two letters. First two letters here, AB, that makes one side. AB makes one side. Of course, we know AB is one side here. Right? Here BD, AB, BD divided by BD. Right? In divide will be equal to BC. Second and third letter BC is one side. BC is one side. BC. Second and third letter here DC, DC is corresponding to DC will be equal to, now take the first and last letter, AC. AC is one side, we know already, right? It will be here also take first and last letter, that will be PC, right? We got again similarity. We wrote similarity statement and we got the equation. Now this equation has three ratios. But we need two ratios only, as I did in earlier case, right? So I told you already which two we have to choose. Which two we have to choose? We must choose two having one common side, one same side. If I take these two, first and second, here all four sides are different. A, B, BD, BC, DC, all four are different. Don't take this. Now in these two, BC, BC, AC, BC. Oh, BC is same, right? BC is same. In these two ratios, we are getting one common side, BC. So choose that, these two. So this implies BC divided by BC is equal to, we are choosing this and this. We are not taking this because we don't need it, not required. For our, all these three are equal. For our equation which we have to prove, we need these two. That's why we are taking this one. Okay, so BC divided by DC is equal to AC divided by BC. Now cross multiply again. Cross multiply. As we did here. Cross multiply. When you cross multiply, BC will multiply with BC. BC into BC will become BC square. And here if you multiply, it will become AC will multiply with DC. So it becomes AC into DC. We got this. Right. This is equation number 2. Take this as equation number 2. Now, after this, I write here the remaining part. This is the first part, this is the second part, and last part I am writing here. Okay. Now, add equation 1 and 2. Add equation number 1 and 2. Add equation 1 and 2. While adding equation, how do we add equations? LHS is added to LHS, RHS is added to RHS. LHS must be added to LHS, RHS must be added to RHS. Here in this equation number 1, this is equation number 1. In this equation number, what is LHS? AB square. In this equation, what is LHS? BC square. So while adding equations, add 1 and 2. Add 1 and 2. AB square plus BC square. Add equation 1 and 2. Add equation number 1 and 2. When we add equation 1 and 2, AB square will add to BC square. LHS plus LHS. This is equation number 1. This is equation number 2. We are adding them. These two. AB square will add to BC square. So AB square plus BC square will be equal to LHS plus LHS. LHS here AB square. LHS here BC square. We add it. LHS plus LHS. LHS plus LHS will be equal to RHS plus RHS. RHS plus RHS. Here RHS is AC into AD. AC into AD. Plus here RHS is AC into DC. AC into DC. We did this, right? LHS is added to LHS. RHS is added to RHS. Now, here this will remain same. AB square plus BC square will remain same. In this RHS is equal to, in this RHS, see in these two terms are there. Here plus sign is there, right? AC is common. We have AC here, we have AC here. So we can take AC common here. Take AC common. If we take AC common in these two terms, in this term and in this term, because plus sign is there. Therefore there are two terms. One term, second term. So we can take AC common. AC, if we take AC common, from this we are taking AC common. So what is left here? AD. Plus from this also we are taking AC common. So what is left? DC. Right. Now, AB square plus BC square will be equal to AC. This is into here. Now AD plus DC. AD plus DC. Go to the figure. Go to the figure. AD plus DC. Observe carefully. AD, this part, plus DC, this part. If you add this part AD plus DC, that will become the whole line AC. AD plus DC. AD plus DC is AC. Right? We are adding these two parts. So that will become AC. So AD plus DC from figure, AD plus DC is AC. The complete line, right? Now, therefore, AB square plus BC square is equal to, what is AC into AC? AC into AC is AC square. Oh, we got it. We got required equation. See, AC square is equal to AB square plus BC square. Square on the hypotenuse is equal to sum of square from the other two sides. We got it. Same equation you can write like this. You can write AC square here is equal to AB square plus BC square. This is the required equation. This is what we had to prove. AC square is equal to AB square plus BC square. This is Pythagoras theorem. Square on the hypotenuse, AC is hypotenuse. AC is hypotenuse of this big triangle ABC. AC square on the hypotenuse is equal to sum plus sum of squares on the other two sides. Other two sides are AB and BC. Squares of the other two, AB and BC. This is Pythagoras theorem, a very important theorem. Many times it has appeared in exam. It is very useful in 10th as well as in PUC. So learn it well, practice well. If you have any doubt, you can write in comments. I will clear your doubts. Practice it well. Hope you all understood the theorem, and do subscribe this channel. Thank you.